Hi everyone, in this lecture I am going to discuss non-homogeneous differential equation which can be reduced to homogeneous differential equation. In the previous lecture I have discussed the homogeneous differential equation, which is that how can we solve the homogeneous differential equation. So in this video I am going to simply discuss non-homogeneous differential equation which can be converted to homogeneous differential equation. Okay, so non-homogeneous which can be reduced to homogeneous differential equation. So a differential equation which is in this format: dy dx equal to ax plus by plus c divided by lx plus my plus n. Okay, so there will be two cases to solve the non-homogeneous differential equation to homogeneous differential equation. So first case is that if this condition satisfy a by l does not equal to b by m. Okay, means a is coefficient of x, b is coefficient of y, l is coefficient of x, and my is coefficient of, and satisfy this condition. So we will substitute something. Substitute is like that: x equal to s dash plus h and y equal to y dash plus x. Means in this differential equation we will substitute this: x equal to x dash plus h and y equal to y dash plus k. Okay, so where h and k both are constant, here h and k are both are constant. Okay, so equation dx will be interchanged in dx dash and dy will be in dy ds. So equation reduced to dy by dx dash equal to ax dash. Means we are replacing x equal to x dash plus h, y equal to y dash plus k in our original differential equation. Okay, and dx will be interchanged to dx d dash and dy interchanged dy d dash. So after substituting all these things, so this will become differential equation, a new differential equation: dy dx upon dx equal to ax dash by dash ah plus bk plus c divided by lx dash my dash plus lx plus mk plus n. Okay, so now we will put these two, this is in a linear equation. Okay, so we will put these two linear equation equal to 0 and solving these two linear equation by substitute method or elimination method. So then we can find the value of h and k. Okay, so after putting these two equations 0, so this differential equation will be converted in this format: dy dx upon dx ds equal to ax dash plus by dash plus lx dash plus my equal to dash. So in the previous lecture I have discussed a homogeneous differential equation. How can we solve that? So we will put y dash equal to vx dash and we will do the same process like previous lecture. Okay, so I am taking an example and we'll show that how can we solve this differential equation. So example is that dy by dx equal to y plus x minus 2 divided by y minus x by 4. Okay, so solution. So first of all we will substitute. First of all our condition was that a by l does not equal to b by m. So value of a is coefficient of x, that equal to 1, divided by coefficient of x is minus 1, equal coefficient of y is 1 and coefficient of y is 1, which is does not equal to satisfy our first condition. First case, a by l does not equal to b by m. Now we will do replacing x equal to x dash plus h and y equal to y dash plus k in this equation, and dy will be dy dx and dx equal to dx ds. So our new equation will be dy dx equal to y dash plus k. We will replace these values in original differential equation: x dash plus h minus k equal to y dash plus k minus x dash minus h minus 4. Okay, so we can also write plus h plus k minus, this is 2. Okay, this is 2 minus 2 divided by minus x dash plus y dash minus h plus k minus 4. So I am putting these regions linear equation. So we will put these two linear equation equal to 0. So h plus k h plus k minus 2 equal to 0, and minus h plus k minus h plus k minus 4 equal to 0. So after solving these two simultaneous linear equation, I will get the value h equal to minus 1 and k equal to 3. Okay, so our differential equation, after putting these two values 0, so our differential equation will be reduced in d by d dash x, d by dx dash equal to y dash plus x dash divided by y dash minus x dash. So in the previous lecture, in the lecture 2, we have seen the how to solve the homogeneous differential equation. So we will apply, this is an homogeneous differential equation of degree 1. This function is homogeneous function. Okay, so first of all we will do the process. Put y dash equal to vx dash. Now we will do the derivative of first order with respect to x. So these are the function in the two variables, v and x dash both are variables, so we will apply the product rule of the differentiation. So it will come v is as it is, derivative of dx dash equal to dx dash plus x dash is dv upon dx dash. Okay, so it will become v plus x dash dv upon dx. So after replacing these values, so after replacing d by dx, the value of d by dx is this, and the value of y dash is vx dash. So we will replace here these values, then we will get v plus x dv upon dx dash equal to v plus 1 upon v minus 1. Okay, directly I write the directly. Okay, so after solving this, so I will get x dv upon dx v plus 1 minus v minus 1 equal to minus v. So this is basically variables are separable. The terms of v is one sided and the terms of x dash is one sided. Okay, so this is x dash. Okay, so we can say that dx upon d dash equal to v minus 1 upon 1 plus 2v minus v square dv. Okay, we will do the integrating both side integrating. So after integrating we will get v minus 1 upon 1 plus 2v minus v square dv. So after solving this differential equation, this integration, how can we solve this integration? We also write 1 by 2 divided by minus take common 2 minus 2v upon 1 plus 2v minus v square. So this is the integration derivative of the denominator function. So integration will be dx upon dx equal to log x dash equal to, integration of this is minus 1 by 2 log 1 plus 2v minus v square. Now plus c, where c is any constant. So we will replace the value of v is y dash upon x dash. So 1 plus 2 y dash upon x dash minus y dash ka whole square upon x dash ka whole square plus c. Now we will replace the values again. Value again means that value of x dash is x minus h equal to x dash and y dash equal to y minus k, and we also know that value of h and k. So we will put here value of h and k is are minus 1 and 3. So we will replace here log value of x dash is x minus h, value of h is minus 1. So it will become plus 1 equal to minus 1 by 2 log 1 plus value of y dash is y minus k to y plus 3 upon x dash x minus 3, means basically we can write minus this will be the final solution. 2xy minus 5 square minus 4x plus 8y minus 14 equal to C. Okay, this is our final general solution of a given differential equation. Okay, so our main question is that first of all we have given non-homogeneous differential equation because this function is not homogeneous, so we can say non-homogeneous. So we will do convert non-homogeneous to homogeneous, then we will solve the same approach we have did in the we have done in previous lecture. Now I am going to discuss second case also. In the first case it was that a by l does not equal to b by m. Okay, now in the second case I am going to discuss a by l when a by l equal to b by m. So this type of differential equation we will substitute lx plus my equal to t, then we can solve in differential equation with the help of variables are separable. So in this example, let us suppose that this is a non-homogeneous differential equation, but here a by l equal to b by m. Okay, means 1 by 2 equal to 1 by 2. Okay, so here first of all we will do put x minus y equal to t. So here we will do the derivative of with respect to x, to 1 minus y dash equal to dt upon dx. Now we will replace the value here, so it will become 1 minus dt upon dx equal to value of x minus y is t plus 2 and 2t minus 4. Okay, so it will become 1 minus t plus 2 2t minus 4 equal to dt upon dx. Okay, so this is in variables are, this differential equation in variables are separable. The terms of t is one side and the terms of x is one side. So it will become it will become 2t minus 4. I am writing directly 3t minus 2 dt equal to dx. Okay, and we'll do integrate both side. So this integration is we can solve like 2t minus 4. So we will make 3t minus 4, 3t minus 2 in the numerator part. So 2t minus 4 plus t add. Okay, minus t is subtract to 3t minus 2 dt equal to dx. So it will become 2t minus 3t minus, this will be at 3t minus 2 upon 3t minus 2 plus minus t minus 2 upon 3t minus 2 dt equal to dx. Okay, so this will be 1 dt plus, and now again we will do the same 1 by 3 multiply by minus 3t minus 6 upon 3t minus 2 dt equal to dx. So we can also do again the same thing. So it will become 2 by 3 equal to 1 minus 4 3t minus 2 dt equal to x plus c, because the integration of dx is x and we will do where c is any constant. So it will become 2 3t minus log 4 by 3 log 3t minus 2 equal to x plus c. Now we will substitute the value of t is x plus y or x minus y, x minus y. So we will replace the value of t, so it will become 2 by 3 x minus y minus 4 by 3 log 3 x minus y minus 2 equal to x plus c. Okay, so this will be the general solution of an differential equation. So basically we have discussed two cases when a by l equal to m and when both are equal. Okay, so basically our given differential equation was that non-homogeneous, then we convert in the homogeneous, and after converting the homogeneous differential equation we solve by the previous, based on the previous lecture method. Okay, so in the next video I want to discuss the linear differential equation, first order of linear differential equation. Okay, thanks.